Good morning, Chem 20s. We're going to look at Part C, Solution Chemistry. So when we see the word solution, we know that we're going to be working with concentration, and so we're going to have the components of volume and moles. When we're going to use the concentration. And you need to remember that concentration can be given you in an amount. It can be given to you in parts per million. It can be given to you like this. It could be given to you, parts per million is milligrams per liter. There's multiple different ways of coming at concentration, but when we're doing solution chemistry, stoichiometry, we need moles. Okay, so always you need to get from this point, you need to get back to moles. You need to get from this point back to moles. There's a bunch of different ways. You could be given percent volume by volume or percent mass by mass. You have to get back so that you can figure out moles. Let's look at an example here. What volume of 14.8 moles per liter of potassium hydroxide is needed to react completely with 1.5 liters of 12.9 moles per liter of sulfuric acid? I'm just going to go back. We're going to write a refresher. What do we need? We need a balanced reaction. We need to get our moles of our given component. We need to look at the mole ratio between what we want over what we have. And we need to then go from our mole ratio into our concentration of our wanted. So you can see we're always coming back to the mole ratio, but this is the biggest step, balanced reaction. You have to be able to balance compounds and then balance your reactions. Okay? It's such a crucial step. If you're struggling, you need to speak up and you need to get the extra help. You need to be good and proficient in this piece here, in order to be successful in anything else. You have to advocate for yourself if you're struggling. Okay, let's go back to this question. What volume of potassium hydroxide is needed to react completely with sulfuric acid? Well, first we have to build a balanced reaction. KOH is reacting with sulfuric acid. How do I know that this is sulfuric acid? Because it's aqueous. This one here is also in solution because it gives us the concentration. So I have 14.8 moles per liter of this, and I have 1.50 liters of sulfuric acid at this concentration, and it's asking us to find what volume. We're going to get potassium sulfate and water. Okay. I am going to always write water like this from here on out because it's easier when you see a hydroxide ion to look at this as being a hydroxide ion, and as opposed to trying to balance that out. They're the exact same thing. It just clicks in people's brains better when you see water as a hydrogen and a hydroxide ion, because then when we go to balance, I have 2 hydrogens here. It's easier to see that I need 2 hydrogens here. I now need 2 hydroxides. So I put in 2 hydroxides. I now need 2 potassiums, and I see I have 2 potassiums. If I left this as water, you would have to really think that this is 3, and then how do I get a balanced out reaction? So it really is truly easier if you can separate out water into hydrogen and hydroxides and consider them different or separate components. Okay, so we're always going to start with what we were given. We were given 12.90 moles per liter, a concentration of sulfuric acid. And we were also provided the volume, because the first step that we need to get to is we have to get to moles given. In order to find moles, we are going to multiply our concentration by our volume. So I'm going to go 1.5 liters here. Next one is our mole ratio. Our want over our have. And when I look back at the equation, I have 1 mole of H2SO4 for every 2 moles of potassium hydroxide in a reaction. And now I want I want volume of potassium hydroxide, and volume can be found by moles over concentration. So I would go 1 over 14.8 moles. All I've done is I've taken my units for concentration, right? Concentration equals moles per liter, and I've just inverted them because I'm dividing it. It's the same as 1 over moles per liter, right? Will also give me liters per mole. And this is step number 4, our wanted concentration. And so when we do all that math out, we should get a value of 2.61 liters of potassium hydroxide is required. When I look at unit analysis, I'm going to go, my liters cancel out, my sulfuric acid cancels out, my moles cancel out, and I'm left with potassium hydroxide and a volume. That's what I'm left with, and it works out that that's what I'm looking for. Okay, if you needed to do it step by step, this is still step number 1. This is the biggest one. Don't miss this step. Number 2, which is your moles given. Well, I know that N is equal to C over V, so I'm going to take my 12.9 moles per liter, and I'm going to divide it by 1.5 liters. No, I'm not going to divide it. I'm going to multiply it by 1.5. What did I do? I rearranged wrong. CV. And I'm going to get 19.35 moles of H2SO4. Then I'm going to do step number 3. I'm going to look at my mole ratio between H2SO4 and KOH. So from my reaction, I can see that I have 1 mole here and I have 2 moles here, because this is always from our coefficients in the reaction. So I have 1 mole of H2SO4 and I have 2 moles of KOH, which is going to leave me with a value of right? Because this moles of H2SO4 and that moles cancel out, and I'm left with moles of KOH. Then in step number 4, which is calculate out the concentration of our wanted solution, I'm going to go 38.7 moles. You're going to have kept all of your decimals to this point, and concentration is equal to, I'm not looking for concentration, I am looking for volume. So volume is going to be equal to N over C. I'm going to divide this by the concentration of KOH, which is 14.8 moles per liter. And I see that I'm going to get a value of 2.61 liters of KOH. So the same 4 steps that were done here linearly, all in one line, gets done in each step, 1, 2, and 3. Okay? But I'm going to push you to do it linearly. So you're going to not worry about working on any questions. We're going to move into law of combining values. Law of combining volumes. And so we can use the law of combining volumes when the pressure and temperature conditions are constant for both the reactants and the products. Okay, so what are some pieces that we need to look at when we're doing this? We need to be aware of mole ratios. So again, we need to make sure that we have a balanced reaction. We need to understand that temperature and pressure are constant. And then we can calculate for our wanted. Let's look at some examples. So some examples of this will be nitrogen and oxygen react to give us a dinitrogen tetraoxide. What is the mole ratio for oxygen and dinitrogen tetraoxide? Well, it's been balanced for us. So oxygen is 2 and dinitrogen tetraoxide is 1. That's the mole ratio. What is the volume ratio for oxygen and N2O4? When I look at oxygen, there's going to be 2 to 1. This is assuming that temperature and pressure are constant. Okay? If 1 mole of dinitrogen tetraoxide is produced, how many moles of oxygen must be consumed? 1 mole of nitrogen tetraoxide is produced. How many moles of oxygen must be consumed? We want oxygen, and there's 2 of them. and we look at dinitrogen tetroxide and there's 1, so there must be 2 moles of oxygen consumed. If 1 liter of dinitrogen tetroxide is produced, what volume of oxygen must be consumed? I have 1 mole of N2O4 in the reaction, and I have 2 moles of O2. Again, it always comes down to mole ratio. That's the only way that you can compare different species. It's going to be 2 liters of O2. If 2.5 liters is consumed, what volume of oxygen must be consumed? Again, mole ratio, only way that we can compare. So there's 2 O2s and 1 N2O4. So we would get 5 liters of O2 would be consumed if N2O4 was consumed. So now you're going to stop the video and you're going to work at pages 12 to 13 in your workbook.